In this video, we're going to investigate conic parabolas. I know you've had experience with parabolas in the past, graphing them as squared functions, in other words, second-degree polynomial functions. We're going to take a slightly different perspective on things and look at them as a conic. And throughout this lesson, 10.1, in 3 parts, we're going to talk about the formula itself and all of its parts, and then use those general equations to graph parabolas, and then the opposite, take a graph and write those equations. So let's jump right in and look at the way parabolas work from a conic standpoint. So this is going to, you'll see this constructed as it goes, but basically we have this line that's called the directrix. I'm just going to talk over this as it animates. This line is called the directrix. It's this line in space. And then you got this one point, this single point called a focus. And this focus combined with this directrix is what constructs, is what creates the parabola. The midpoint of the length from the focus to the directrix is called the vertex of the parabola, which you've been familiar with in the past. That's this point right around there. Okay, oops, sorry about that. It'll reanimate. But the midpoint between the focus and the directrix is the vertex of the parabola. And what happens is the parabola is the set of all points that are the same distance, at equal length, from this focus and this here directrix. So that parabola is the set of all points that are equidistant from the directrix and the focus. So that original point there was the what we knew as the vertex. All right, so there's a lot of little measurements, a lot of things going on. Forgive that phone ringing interruption. But so as you can see, there's a lot going on when it comes to the graph of a parabola. But it lays out here in text the definition of parabola that I gave in the previous slide. But it's a set of all points that are equidistant from that fixed line called the directrix and the focus, which is some point nominal line. But it gets that basic parabolic shape going on. And so you see kind of some things here, y equals negative p and x and y and d1, d2, all that kind of stuff. What's really, really important is to notice this. The vertex is that minimum point right here. The focus, it opens towards the focus, and it opens away from the directrix. The focus, the vertex, and the directrix you're going to be able to pull out of the general equation of these parabolas. But it's important to note that physical relationship. Okay. Now, in class, we'll talk about what this focus really means and things of that nature. But when it comes to constructing them through the vertex, vertex is one of the points on the parabola, opens up towards that focus, away from the directrix. And now, for the first time, you're going to encounter some horizontal parabolas as well. These are not functions in the sense of one input, one output function notation, but they are graphable as conic sections. So we can actually have horizontal parabolas as displayed here, and vertical parabolas. And what you're going to be able to do is tell the difference based on the equation. So if we go back to this slide, you see this big monstrosity of a general second-degree function. And what's going to happen is, based on the values and coefficients of certain terms of this monstrous function, you're going to be able to tell what kind of parabola it is. In fact, you can tell just by looking at the general form. So what happens is, you've got 2 different forms. The standard equation of parabolas. The vertex is always this point hk. What happens is a parabola with an x squared over here is a vertical parabola, just like you've always known. X squared equals y. We'll talk about this p and this h and this k business in a minute. And then so instead of having an x squared for a vertical, a horizontal parabola has a y squared. Like I said, we'll talk about the h, k, and p in just a second. But basically what's going to happen is each of these values, x and y are of course our variables, but each of these values, this h value, p value, and k value, are going to tell you something different about the graph. as it says up here, HK is the vertex of the parabola, no matter whether it's horizontal or vertical. The H value is the value that's being subtracted from X. K, the value is 1 subtracted from Y. You can read. And this P value is basically a way of determining how thin or wide the parabola is. Okay? Now, this P value is a directed distance. It gives you the distance from the focus to the vertex. So if it's positive, it goes up. If it's negative, it goes down. If it's positive, that would be in a vertical parabola. If it's positive, it goes right. If it's negative, it goes left. Now, as I said earlier, each of those values, K, H, and P, tell you something different about the parabolas. So, to HK is your vertex, of course. Once you determine something is horizontal or if it's vertical, we're going to walk our way through this set of equations and determine where the focus is based on our HK and P values, where the directrix is, Y equals, which means it's a horizontal line at K minus P. And then the axis of symmetry, not necessary, but it's nice to note it's a vertical line that passes through the focus at H. And then we can add to the mix the same set of directions for horizontal parabolas, focus being the H value plus P. You can read. So when we actually go through and do some of these examples, it'll make a little bit more sense, but it'll definitely be good to come and revisit these formulas over and over again. Definitely jot them down nice and neat, because you will be referencing these formulas, these general equations, very, very often. In the next video, we'll start right here with example 2.